Hello everyone, let's talk about simplifying trigonometric expressions. These are like puzzles. If you go into this with the mindset that you're gonna get them wrong the first time, but you just gotta try something else and treat them like puzzles, this is a lot more interesting. If you think that you're gonna be able to look at a problem and do it perfectly every time, this is not for you. I can't tell you how to do every problem because every problem is a little bit different, but I can give you strategies. So when we go through these problems, you need to understand, try something. Try something. You'll usually figure them out because there's only a couple things we're going to really have to deal with too much. So my first strategy will be, if you ever see a trig function that is not sine, cosine, sine or cosine, we're going to convert it into sine and cosine. So we think of cosecant. Cosecant is the reciprocal of sine. So I'm thinking that's 1 over the sine of theta. Secant is the reciprocal of cosine. And tangent of theta is sine over cosine, if you think about it in terms of y over x, which means cotangent is the cosine over the sine of theta. So if you ever see a trig function that is not sine or cosine, your first strategy could be convert everything into sine and cosine. If you work in just sine and cosine, oftentimes you will be very successful. The other thing that you're going to see quite a bit of is these Pythagorean identities. So you need to have these memorized. The first one and the most important one is sine squared plus cosine squared equals 1. This is the Pythagorean theorem in trig. It is the Pythagorean theorem, but it's instead of sine, which is y squared, and cosine, which is x squared plus y squared equals 1. If you look on the unit circle, any point on the unit circle has a radius of 1. And this is x, and this is y. So we're doing the Pythagorean theorem. X squared plus y squared equals 1. It's just in terms of sine and cosine. Now, there's two other Pythagorean identities, and you can pretty easily figure them out if you know this one. The first one, if you divide everything in the problem by sine squared, sine over sine is 1. Cosine over sine is cotangent. And 1 over sine is cosecant. So 1 plus cotangent squared is cosecant squared. That's another Pythagorean identity. I'll do the same thing over here, but I'll divide everything by cosine squared theta. So sine divided by cosine, sine over cosine, that's tangent squared theta. Cosine divided by cosine is 1, and 1 divided by cosine squared theta is secant squared theta. So we have another trig. These are called Pythagorean identities. 1, 2, 3. Those are Pythagorean identities. You're going to see them. And really, the giveaway, if you ever see something is squared and a 1, you're almost certainly going to see a trig identity. So we've kind of got these ideas, but we haven't actually done any problems. Now let me show you the sorts of things that you will be doing with this sort of concept. It says simplify the trig expression, which means I can make this a lot easier than cosine of t plus tangent times sine of t. And the way I'm going to do that is I'm going to start off by converting everything in terms of sine and cosine. So cosine of t, hey, your cosine of t, plus the tangent of t is the sine of t over the cosine of t. And the sine of t is the sine of t over 1. So now what I have is cosine plus sine times the sine in the top, which I'll write as the cosine of t, and I'll put that over 1, plus this is sine squared t over cosine t. So first thing we've done is make everything in terms of sine and cosine, and now what we're going to do is get a common denominator. So if this guy has cosine for its denominator, this guy needs a cosine for its denominator. So I'll multiply the top and the bottom by cosine. When I do that, my denominator is now cosine, which they both have the same denominator, so I'll just write cosine at the bottom. And in the top, I'm just looking at the top now, cosine times cosine is cosine squared, and sine squared is sine squared. Now, this is where you're going to have your spidey sense that's telling you, wait a minute, this might be a thing. And it's right here. You see cosine squared plus sine squared. Come back here and you're like, cosine squared plus sine squared, that's the thing. Cosine squared plus sine squared equals 1. So right here, what I'm going to do is now say, instead of cosine squared plus sine squared, I'm going to say 1 over cosine of t. And then, like, 1 over cosine of t, 1 over cosine is the secant of t. So this whole thing simplifies to the secant of t. which is, if you're trying to do something like in a calc class, going to make things a lot easier to deal with than this mess. So we've taken this whole expression, we've simplified and said, well, actually, that's the same as secant. And that's the whole game here. We're trying to reduce them as much as we can, and the main strategies are convert everything into sine and cosine, and then look for Pythagorean identities. Let's try another one. Let's see. First of all, I don't see anything that's squared. If I saw something that was maybe squared, I'd try something different. But since I don't see anything squared, I'm going to, I think I'll just FOIL it, and then I'll make everything in terms of sine and cosine. And I don't know if that's the best game plan, but it's pretty much my only strategy right now. So let's do 1 times secant is secant, and 1 times negative tangent y is negative tangent y. And sine times secant, we'll just put plus sine of y times secant of y. Minus sine times tangent. Sine of y times tangent of y. Okay, now that I've got everything expanded, I FOILed it, let's make everything in terms of sine and cosine and see what happens. The secant is 1 over the cosine of y. Tangent is the sine of y over the cosine of y. Sine of y over 1 times 1 over cosine of y minus sine of y over 1 times tangent is sine over cosine. So what did I do there? Secant is 1 over cosine. Tangent is sine over cosine. Again, secant is 1 over cosine. And tangent is sine over cosine. So all I did was go through and just put everything in terms of sine and cosine. Let's see, did that help us at all? Cosine, cosine, cosine. All my denominators are cosine. That's nice. Okay, so I'll write these. This big fraction bar is all over the cosine of y. And what do I have in the top? 1 minus the sine of y plus the sine of y minus, that's sine times sine is sine squared of y. So what happens? Those cancel out. Sine minus sine is 0. And then you have 1 minus sine squared. And you're like, hey, wait a minute. 1 minus sine squared, that's a thing, probably. I think that's probably a thing. Let's come back here. 1 minus sine squared. 1 minus sine squared. What's 1 minus sine squared? I feel like here, if you take that equation and you subtract sine squared theta on both sides, you have cosine squared theta equals 1 minus sine squared theta. So instead of 1 minus sine squared theta, I'm going to come back to this problem and say, 1 minus sine squared theta is cosine squared. So this is cosine squared theta over cosine of theta. And if you imagine that's x squared over x, you can think of it as like x times x over x. One of them cancels out, and you just have the cosine of y left. There's 2 in the top, there's 1 in the bottom, 1 cancels out, you're left with 1 cosine on top. So this whole thing simplifies cosine, which again is much nicer to work with. If I said graph this, we would all fail. If I said graph cosine, we did that already. We could probably do that. Let's keep rolling. All right, another fraction problem. If I see things that are not sine and cosine, my main strategy is write them in terms of sine and cosine. So instead of secant, I'm going to put 1 over cosine, and then in my denominator, tangent is sine of x over cosine of x. So this is a rational trig function. Let's see what I can do here. I need a common denominator on the top. Let's give this guy cosine of x. All right, so in the top, and you guys might remember when we did rationals, we did this exact same thing. We get a common denominator in the top, which is cosine of x. And in the top of the top, in the numerator of the numerator, I have 1 over cosine squared. Because cosine times cosine is cosine squared. In the bottom, I still have sine of x over cosine of x. So I am going to copy, change, flip. Copy, change, and flip. Now it's cosine of x over sine of x. So this, change this to multiplication, and then flip. Now it's cosine over sine, which you'll notice, now these are quantities. Unless the whole thing cancels, nothing cancels, but cosine can cancel. And then I have 1 minus cosine squared, which I'm like, wait a minute, 1 minus cosine squared. I could do the same thing here, subtract cosine squared, and I would say sine squared theta is 1 minus cosine squared theta. So instead of 1 minus cosine squared, I'm going to put sine squared. Now I can cancel out 1. and I have sine of x. So the whole thing simplifies to the sine of x. We have this big fraction, we just simplified to sine of x. Let's try on example 4. Everything is in terms of sine and cosine, so I can't really do that. I don't see anything squared, so I can't really do that. So really, the only thing I can do is get a common denominator and hope that it works for me. So let's multiply the denominators times each other. And now I have, as my denominator, cosine of theta times 1 plus sine of theta. I'm just going to leave that alone, because I don't know what's going to happen. But let's deal with the top now. So 1 times sine, I'm distributing. 1 times sine of theta is the sine of theta. Sine of theta times sine of theta is sine squared theta. And cosine squared, or cosine theta times cosine theta is cosine squared theta. So first thing, hey, look at that. Sine squared plus cosine squared. You should be thinking, that's a thing. That's my spidey sense. Oops. That simplifies to 1. That's a Pythagorean identity. So in the top now I have 1. That's 1 plus sine theta. 1 plus sine theta over cosine of theta. Look at this. 1 plus sine theta. And hey, that 1 plus sine theta can cancel out with this 1 plus sine theta. And now I have 1 over cosine theta. 1 over cosine theta is the secant of theta. Nice. Cool. So again, they clean up nice. These are all going to be very friendly. They should be very simple and interesting. Let's see. Okay. I have things that are not sine and cosine. So let's start with that. I know I'm gonna have to get a common denominator in the top. Sine of theta. And then cotangent is cosine over sine of theta. And cosine is cosine of theta over 1. And then the denominator, I have cotangent, which is cosine of theta over sine theta. So let's see, what can I do? Let's get a common denominator in the top. So I'll give this guy sine of theta in the top and the bottom. And now I have sine squared theta plus cosine squared theta over sine of theta. And in the denominator, I still have that's cotangent, which is cosine over sine. So I will copy, change, flip. Well, wait a minute. I'm seeing something here as I do this. I'm like, this is a thing. Sine squared plus cosine squared. Yeah, that's going to be a thing. This is sine of theta over cosine of theta now. So these flipped, and now it's sine over cosine. That says sine. So let's see. First thing, sines, those can cancel out. Those are both, like, sine divided by sine is 1. And then you have sine squared plus cosine squared. That's 1 over cosine theta, which is, again, secant theta. Nice. So you can see how these things are going to clean up a lot, and you're going to end up with much simpler answers than maybe you realize. Like, they should all be very friendly. Let's see what else we got. Okay, practice problems. So this is where you need to try and do these problems and maybe get them wrong a bunch of times. That's part of the game. They are puzzles. If you do a Sudoku puzzle and you don't immediately know the number, it's not like, well, I guess I can't do it. You gotta play with it a little bit. So try and make everything in terms of sine and cosine. Try and get a common denominator. You're going to see the same skills in most of the problems. They just come at slightly different times, and you might do the problem in a different way than me, but we will all end in the same place. So hit pause, give them a shot, then hit resume, and watch me do them. I'll go through them with you in a minute, but you do them first. I'm going to go through them now, so I hope you actually did that. So this is the cosine of t times tangent is the sine of t over the cosine of t. Now, if you write cosine as cosine over 1, you can see those cancel out, and this is just the sine of t. Cool. Tangent squared minus secant squared. That might be a thing. Let's see. Do I have one with tangent and secant? I do. Tangent squared minus secant squared. Well, if I know that I can do a trig substitution, I might as well do that. So, but I think that since probably most of us didn't do it that way, I'll write it out, and then I'll maybe show you how you could do it sort of a faster way. So if you look at it this way, make everything in terms of sine and cosine, now you have cosine squared x in the bottom and sine squared x minus 1 in the top. Sine squared x minus 1. Sine squared x plus cosine squared x equals 1. So what is sine squared x minus 1? Sine squared x, if you subtract 1, then you have to subtract cosine. So this is negative cosine squared x. Sine squared of x minus 1 is negative cosine. And then these will cancel, and you'll just end up with negative 1. That's cool. Now another way you could have done that, tangent minus secant. Tangent minus secant. Come up here and look at this and say tangent minus secant. If you subtract secant squared on both sides, so now you have tangent squared theta minus secant squared theta. You have this 1's move over, now it's negative 1. So tangent squared minus secant squared is negative 1. You can do it with the trig identities, the Pythagorean identities, or you can just go through and work it out. You get the same thing, but you'll see as these get harder that some of the times you might want to try one thing, it doesn't work, and then you try a different thing, it works a lot better. Let's keep going. I'm going to distribute. Actually, you know what? I'm going to first make everything sine and cosine, because that's kind of my main strategy still. And I think when I distribute, it's going to be nice. So cosine squared times 1 is cosine squared theta. And cosine squared times sine over cosine squared, these will cancel, and you'll just end up with sine squared theta. So this ends up being cosine squared plus sine squared theta, which, hey, that's a thing. It's 1. This equals 1. So we have 1 that equals negative 1. We have 1 that equals positive 1. Yeah, they clean up nice. One more. Cotangent is the cosine of theta over the sine of theta. And this is all over. Cosecant is 1 minus sine of theta minus sine of theta, which is sine of theta over 1. And I'll get a common denominator. So cosine of theta over sine of theta divided by. So that means this guy's going to need a sine on the top and the bottom, so it'll be 1 minus sine squared theta over sine theta. If I multiply this guy by sine over sine, sine times sine is sine squared, and now the denominator is sine, so I can write it as one fraction. Copy, change, flip. So I got cosine over sine. Change to multiplication. Now flip it. Sine of theta over 1 minus sine squared. That's cosine squared theta. I'm just going to do that while I'm thinking about it. This is cosine squared theta. That's a Pythagorean identity. Subtract cosine squared. 1 minus sine squared, you get cosine squared. And what can I cancel out? Those cancel. One of these cancels. So it's 1 over cosine, which is secant theta. Nice. Okay, so they all cleaned up a lot. Which the idea here is we're making ugly things that are very messy much simpler, so that we can then use those to go to basically advance the problem. So you've got some practice problems. Make sure you look at those. You've got your school assignments. Make sure you get that done. And while you're at it, make sure you hit that like and subscribe button.